Hello and welcome Skyhawks back to another episode of SIP Zoyas, your semi-daily dose of math curriculum. Our topic for today is going to be the axis of symmetry, and the axis of symmetry is a line which perfectly splits an image such that both sides look like mirror images of each other. We have an example of what that looks like over here, and notice this is an axis of symmetry because when we draw this line, it splits our image so that our right side is a perfect reflection of our left side. Right? It looks like this side is reflected in a mirror across this line over here. So for a parabola, which is ultimately what we're going to be using this with, the line is always at the vertex. Right? So our vertex is right here, and our axis of symmetry is always going to be going through the vertex, traveling in the same dimension as which the parabola opens. So if our parabola is opening vertically, that means our axis of symmetry will be vertical. If our parabola is opening horizontally, that means that our axis of symmetry is going to be horizontal. And we're going to see some examples of what that looks like. Okay, so our steps for finding the axis of symmetry is first going to be number 1, finding the vertex, which we like to call h comma k. No good reason for that, but remember h is the x value of our vertex, and k is the y value of our vertex. So we're first going to find our vertex, and then step 2 is we're going to determine if our parabola opens vertically or horizontally. And remember, that's because our axis of symmetry is going to be traveling in the same way that our parabola is oriented. So if it's oriented vertically, it travels vertically. If it's oriented horizontally, it travels horizontally. Okay? Once we have those two pieces of information, then for step 3, if our parabola is vertical, the axis of symmetry is going to be x equals h, or the x value of our vertex. If it's traveling horizontally, then the axis of symmetry is going to be y equals k, which k is the y value of our vertex. Let's go ahead and take a look at some examples now. So step number 1, we want to find the vertex. So our vertex is right here, and that vertex is going to be -3, -5. Alright? And now we want to go on to step 2, which is determine if the parabola opens vertically or horizontally. So we can see here that our parabola is opening vertically. It's opening downwards, but more generally it's in the vertical direction, the vertical orientation. And so our parabola is vertical, so that means that our axis of symmetry is going to be x equals h. And h is -3 because that is the x value of our vertex. Notice how if I draw this line x equals -3, it's going to go right here. Right? This is the line in which all x values must equal -3. Which looks good. That looks symmetrical. That looks like the axis of symmetry which we're looking for. Okay, so next example. So we're looking for the axis of symmetry, and step number 1, we want to find the vertex. So our vertex is right here, and so that's going to mean that our vertex is 1, 5. And now we want to determine if our parabola is opening vertically or horizontally. And here we can see, right, it's opening horizontally. You can see it going kind of like this. And so it's opening horizontally, and so that's going to mean that our axis of symmetry is going to be y equals k. And remember, k is the y value of our vertex. So our axis of symmetry is going to be y equals 5. And if we were to go ahead and draw the line y equals 5, remember, it's just all the points that have y equal to 5. Right, so going up, y is 5 right there. So it would be all these points on this line. And we can see how that perfectly splits our parabola in half. It creates a symmetrical image, which is good. So that's our axis of symmetry. Okay, moving on. So we have an equation right here. So still, step number 1, we want to find our vertex, but we have to find it from an equation. So this is where we're going to use some of our prior knowledge, and we're going to recognize this as our translational format of a parabola. And when we see our translational format of a parabola, I'll go ahead and write it here so that way we can remember it. We see a times x minus h equals y plus, y minus k squared. That's the translational format of our parabola, in case you weren't sure. And so that just means our vertex is going to be 5 for the x value, and k, not positive 2, but negative 2. Notice how that negative doesn't quite match up. So if we wanted to get that to match up, we would need a negative 2 right there. So k would be negative 2. Okay, and that's our vertex. And so we found our vertex. Now we want to go ahead and determine if our parabola is opening vertically or horizontally. And how you can tell when looking at an equation is if our y variable is squared, it's going to be opening horizontally. If our x variable is squared, our parabola will open vertically. So we see our squares on our y value, so that means that it's opening horizontally. And so if it's opening horizontally, that means that our axis of symmetry, I'm just going to abbreviate it as AOS, is going to be y equals negative 2. And I actually included images of what these graphs look like. Granted, we're not given these, so you don't want to assume we can just look at it and tell, but this is more just to kind of prove our answer. So down here we see our graph, and if we were to draw the line y equals negative 2, it would go through right here all the y values that are equal to negative 2, right there. Which is good. That looks like our axis of symmetry perfectly splits this image in half, creating a symmetrical image, or showing where it's symmetrical. Okay, cool. Next one. So, again, we want to go ahead, we first want to find our vertex. And so if you notice, this is in vertex form, and so I'll go ahead and write out our vertex form. Our vertex form is going to look like this. Okay, and our vertex is still going to be h comma k. Remember, this is something that, this is prior knowledge, so if you're not sure about this, you want to go ahead and brush up on that. But so, once we see this, we see that our x value, our h value, is going to be 5. And we see that our y value is going to be 2. Okay, so our vertex is 5, 2. Many different ways you can think of this, but please always remember that our h value is always associated with x, and our y value is always associated with k. And looking back really quickly, that's why we drew our h over here with our x, and our k with our y. They always want to go with each other. X comes before y, h comes before k, so they associate with each other. Alright, so that is our vertex. Now we want to determine if this is opening vertically or horizontally. Remember, if it's opening vertically, it's going to have x squared, which is what we see here. We see x is squared, so it's opening vertically. If we were opening horizontally, y would be squared, and we don't see that here. So this is opening vertically, so our x, or our axis of symmetry, is going to be x equals h, but remember h is the x value of our vertex, so 5, so x equals 5. And I know we might think this is a horizontal line because we see x, but remember this is saying all of the x values that are equal to 5. And so if we were to look at this, it would be a vertical line because you're only going over 5, but then you can move up and down as much as you want, right? This fixes our x value but not our y value. That's why it creates a vertical line. And again, let's go ahead and look at what this looks like on our graph. We weren't given this, but we can always go ahead and check it by finding out what the graph looks like and then plotting it on it. So x equals 5 would be the line that goes over 5 and then up and down as much as it wants. Right? We have no parameters on how much it can go up or down, and so that would be our line x equals 5, and we see that it makes that axis of symmetry.